Between the two world wars, the British aviation industry went through a fascinating period. To meet the military's needs, engineers turned out a huge variety of wildly different experimental aircraft. Even back then, it was well understood that only a handful of these prototypes had a real shot at landing a contract and going into full-scale production. Still, it was a relatively peaceful era. New aircraft only cost a few £1,000s back then, so they could be designed, built, and fully flight tested in just a matter of months. And while peacetime budget cuts meant the Royal Air Force couldn't always adopt the latest designs right away, this approach had one major upside. It allowed design teams to keep working, experimenting, and pushing engineering forward, both in airframe design and engine development. Armstrong-Whitworth's history includes 4 notable aircraft that ultimately failed to win those lucrative government contracts. None of these 4 aircraft ever made it past the prototype stage, so they never took center stage in the company's official history. But you shouldn't write them off. Every single one of these aircraft helped push aviation technology forward. For us, they are interesting primarily because of their unique engineering features and innovative thinking, rather than their combat record, which, let's be honest, didn't really exist. The first of these was a military transport called the Awana. This was the first clean-sheet, independent design from Armstrong-Whitworth. It was a radical departure from the aircraft they had been building up to that point. Up until then, the company's aircraft work had mostly meant licensed production and designs credited to hired talent. During the First World War, its aerial department had turned out around 100 IRE-7 reconnaissance biplanes under license, and for a few years it also employed the Dutch designer Frederik Koolhoven, whose initials gave rise to the company's early FK series of aircraft. It was only in 1920, when the aircraft business was reorganized into the newly formed Sir W.G. Armstrong-Whitworth Aircraft Company, that the outfit truly began charting its own engineering course. The Awana was one of the very first products of that new, independent chapter. At the time, the company hadn't yet set up its standard model numbering system, but looking back, this transport definitely deserves the honorary designation of AW1. The requirements for this machine came from an official document, Air Ministry Specification 520, issued back in 1920. It called for a twin-engine troop carrying aeroplane capable of hauling 25 fully equipped soldiers over a distance of 400 miles. On top of that, the design had to cope with landing on rough, unprepared ground. And if one engine failed mid-flight, the aircraft still had to be able to stay airborne on the other. The Air Ministry placed its order for 2 prototypes on the 27th of June, 1921, giving Armstrong-Whitworth roughly 2 years to turn the specification into a flying machine. For its time, the Awana was an absolute giant. It was a massive biplane with a wingspan of over 100 feet. It was designed with one specific goal in mind: to quickly and comfortably carry 25 fully equipped troops. Powering this massive aircraft were 2 Napier Lion engines, each producing 450 horsepower. Interestingly, this was pretty unique for the company's early projects. It would be another 15 years before Armstrong-Whitworth decided to use engines from an outside manufacturer in one of their aircraft again. Built to meet an official government specification, this giant was meant to go head-to-head with another famous transport, the Vickers Victoria. To put the Awana's size into perspective, official figures give a length of 68 feet, a wingspan of 105 feet 6 inches, and a height of 20 feet 3 inches. The wings alone covered roughly 2,300 square feet, an enormous area for a single airframe in that era. Despite all that bulk, the empty weight came in at 10,000 pounds. Once loaded up with troops, fuel, and equipment, the gross weight climbed to 24,100 pounds, meaning the useful load actually exceeded the weight of the bare airframe. In the end, only these 2 prototypes of the Awana were ever completed, a fact that only underlines just how much time, money, and engineering effort went into each individual aircraft during this experimental era. In the early 1920s, the government ordered 2 prototypes from each manufacturer, and this is where an amusing bureaucratic mix-up happened. Thanks to a clerical error, the first Awana accidentally received a serial number that actually belonged to its Vickers rival. The mistake was eventually sorted out. The aircraft was given its correct serial, thankfully before the first photos of the plane made it into the aviation press. That correct serial, J6897, ended up belonging to the very first Awana prototype to leave the factory. The Awana featured mixed construction, which was standard for the time. The fuselage frame was built from steel tubing braced with wire, all of which was covered in doped fabric. The wings, however, stuck to a more traditional design, using standard wooden spars and ribs. Overall, the airframe took the shape of a 4-bay staggered biplane, with the fuselage itself built as a deep, almost box-like structure to accommodate the troop cabin below the wings. The engines were mounted just ahead of the lower wing and were housed in aerodynamic cowlings. But the most interesting feature was the cooling system. The engineers used special honeycomb radiators hinged directly beneath the engines. Depending on the temperature and flight conditions, the pilot could raise or lower them into the slipstream to control the engine cooling. The Napier Lion itself was a genuine engineering marvel of the period. Its 12 cylinders were arranged in 3 banks of 4, forming what engineers called a broad arrow, or double U-shaped configuration. This compact layout gave a shorter, stiffer crankcase than the more common V12 engines of the day, while the 24-liter displacement and individually machined cylinders made it, for a time, the most powerful aircraft engine the Allies had. A complete Lion engine weighed in at around 860 pounds. Ironically enough, the very same engine type also powered the prototype of the Awana's rival, the Vickers Victoria. So in the end, the contest between the two transports wouldn't be decided by their power plants at all, but by the airframes wrapped around them. That was hardly surprising, given just how dominant the Lion had become. By the mid-1920s, roughly half of all British aircraft in service were flying behind a Napier Lion of one type or another, and the engine would go on to see use in well over 100 different aircraft designs before radial engines eventually took over. To keep such a massive airplane from taking up too much hangar space, the outer wing panels were designed to fold. For ease of manufacturing, and just as importantly to make it easier to transport, the upper wing wasn't a single solid piece. It was actually split into 5 separate sections. These included a center section and 2 outer panels on each side. The joints were located just inboard of the ailerons. The lower wing had a nearly identical modular setup. The only difference was that its center section was split into 2 halves. The tail section of the giant Awana also featured a biplane design. It had a single central vertical stabilizer and 3 separate rudders. But when it came to pitch control, the engineers came up with a clever solution. What looked like elevators on the upper tailplane actually acted as trim tabs to balance the aircraft in flight. Meanwhile, the actual working elevators were located exclusively on the lower tailplane. Beneath the massive engines of the aircraft, the engineers placed 2 separate main landing gear assemblies. They had a distinctive V shape that immediately caught the eye. Each assembly was fitted with dual heavy-duty wheels. To cushion the landing, a dedicated Oleo pneumatic shock absorber was integrated into the front strut. As for the fuel system, aviation fuel was stored in 3 large cylindrical tanks. Each one held 64 imperial gallons. These tanks were neatly housed in the lower fuselage. They were enclosed in a special aluminum fairing to reduce drag. In addition, auxiliary tanks holding 50 imperial gallons each were mounted between the wings, directly above each engine. These functioned on a gravity feed system. Fuel was pumped from the main lower tanks up to the overhead ones using a dedicated wind-driven pump. All told, the fuel system carried a combined 292 imperial gallons, a figure that later showed up in the aircraft's official specification sheet. Accommodations on board were decidedly Spartan. The troops had to sit on basic canvas sling seats, suspended by heavy-duty cables, arranged in 2 long rows running down either side of the cabin with a narrow aisle in between, not unlike the layout of a bus. To even get inside the cabin, they had to climb through a special ventral hatch cut right into the floor. The crew of the aircraft consisted of just 2 people. They sat in open cockpits located in the nose of the transport. The pilot sat on the left, and the navigator, who doubled as a radio operator, sat directly behind him. Roll control was handled by a large wheel on the control column. But interestingly enough, the design didn't feature dual controls. By the time the Awana was ready to fly, Armstrong Whitworth had entrusted the job to one of the most experienced freelance test pilots in Britain. Frank Courtney had learned to fly before the First World War, served as a pilot with the Royal Flying Corps, and afterward built a reputation testing all manner of unusual aircraft for various manufacturers, while also racking up wins in air races such as the London Aerial Derby. Few pilots of the era had flown a wider variety of experimental types, which made him a natural choice for a machine as unconventional as the Awana. Courtney had already claimed victory in the London Aerial Derby back in 1920 and 1923. The very year he first took the Awana into the air turned out to be another strong season for him on the racing circuit as well. The Awana prototype made its first flight on June 28, 1923. At the controls was the experienced test pilot Frank Courtney. He later recalled that handling the aircraft felt a lot like flying many other planes from that era. Its flight characteristics were perfectly acceptable. However, you'd be hard-pressed to call them outstanding or revolutionary. In the fall of that same year, the aircraft was sent to the RAF base at Martlesham Heath for official testing. By the early 1920s, Martlesham Heath had already earned a reputation as the premier home of British aircraft evaluation. Originally set up during the First World War as a testing squadron, it had been reorganized in March 1920 as the Aeroplane Experimental Establishment, the very body responsible for putting new prototypes like the Awana through their paces before any decision on production was made. The final report logged the following performance figures. At an altitude of 1,000 feet, the aircraft maxed out at a top speed of 97 miles per hour. If the pilot held a cruising speed of 85 miles per hour, the transport could remain airborne for up to 4.5 hours. The initial rate of climb was just over 300 feet per minute. The absolute ceiling of the aircraft was 8,000 feet. Getting up to 5,000 feet took the big transport nearly 20 minutes. A figure that gave a pretty clear sense of just how heavily the Awana was straining under its own bulk. Test pilots did uncover a number of issues, though. Taxiing the aircraft, for instance, was pretty tough. Making sharp turns on the runway put excessive stress on the inboard landing gear components. Once airborne, the Awana showed excellent longitudinal stability, and it had good rudder response at normal cruise speeds. But the moment you started your descent on approach, the handling got downright awful. Engineers figured they could fix this by moving the elevators higher up on the tail section. Lateral stability was rated as acceptable. Though at low speeds, the aircraft had a noticeable tendency to drop the nose. The ailerons also had a distinctly sluggish response. On the plus side, visibility from the open cockpit was absolutely fantastic. Even so, experts concluded that a transport this massive really needed 2 dedicated pilots and a dual control system. Flight characteristics aside, the actual design of the aircraft took some heavy criticism too. For example, the upper fuel tanks didn't even have filler caps. Because of this, ground crews had to pump fuel up from the lower mains using standard hand pumps. This grueling process ate up over an hour of precious turnaround time. The fuselage framework ended up being an even bigger problem. Built from steel tubing, it was overly light and prone to flexing. Due to constant vibration and airframe flex, the whole structure had to be routinely inspected and essentially rebuilt from the ground up. On top of that, the propeller tip clearance against the fuselage was dangerously tight. The intense prop wash actually caused the thin celluloid cabin windows to crack. The cargo deck turned out to be too weak. The tail skid just wasn't robust enough to handle the aircraft's gross weight. Ultimately, the engineers handed down a grim verdict. The Awana was going to be an absolute maintenance nightmare for ground crews. Coincidentally, 1923, the same year the Awana took to the skies, was also the year Armstrong Whitworth relocated its aircraft production to the former RAF airfield at Whitley, south of Coventry, even as its design office stayed behind at the old Parkside Works. The company that had built the Awana, in other words, was itself still very much a work in progress. In January 1924, the first Awana prototype was shipped to the Isle of Grain base. It was supposed to sit there until it could be transferred to Farnborough for storage. Meanwhile, the second prototype arrived at Martlesham Heath to continue the flight test program. This second airframe already featured a number of key improvements that the engineers had recommended after those initial flights. For instance, they adjusted the aileron rigging angle relative to the wing. It might sound like a minor technical detail, but in practice, it paid off beautifully. The aircraft became much more responsive and easier to handle during maneuvers, but the optimism didn't last long. On January 23, 1924, a rep from the Air Ministry's Directorate of Research filed a report. This report essentially sealed the project's fate. The document spelled it out clearly. Getting the Awana up to spec and making it meet all the military requirements was simply going to be prohibitively expensive. The report came to an interesting conclusion. On one hand, Armstrong Whitworth's design actually outperformed its rival, the Vickers Victoria transport. This was especially true when it came to takeoff and landing performance. On the other hand, the Awana's overly lightweight airframe and flimsy landing gear practically guaranteed serious accidents under the punishing conditions of operational military service. Plus, the Awana's massive footprint was seen as more of a drawback than an advantage. The troop accommodations inside were noticeably worse than what the Victoria offered. And on paper, the Victoria simply had the numbers on its side. It could climb to a service ceiling of over 16,000 feet, more than double what the Awana could reach, and its range stretched out to roughly 770 miles, over twice the distance the Awana could cover. Even its top speed, at around 110 miles per hour, comfortably beat the Armstrong Whitworth machine. That same report also touched on the experimental metal fuselages. They were built specifically for the Awana to see how the era's cutting-edge metal construction would hold up in the real world. However, actually outfitting the aircraft with this kind of advanced fuselage proved prohibitively expensive. Because of that, the board decided it made a lot more sense to just use the airframe for destructive structural testing. This was exactly as they had planned from the very beginning. No exact blueprints or technical details of this metal fuselage have survived to this day, but aviation historians suspect it was an advanced wire-braced metal tube structure. This specific design would eventually become a signature feature of every Armstrong Whitworth aircraft, right through the end of the 1930s. Ultimately, pragmatism won out. For full-scale production, the military chose the more reliable Vickers Victoria transport. Vickers would go on to build 97 examples of the type, and the Victoria stayed in frontline Royal Air Force service until 1935, seeing extensive use on colonial policing duties in places like Iraq and Afghanistan. The two Awana prototypes that were actually built quietly faded into history. Their final fate remains unknown even to the most dedicated researchers. But it wouldn't be fair to write this project off as a complete failure. The massive engineering effort and the invaluable experience gained from working on the Awana didn't just go to waste. By 1926, all that groundwork was successfully applied to the new Argosy civilian airliner. It inherited several unique design features from its experimental predecessor. The Argosy, a 3-engine biplane airliner built for Imperial Airways, first took to the air on May 16, 1925, with the very first example named City of Glasgow. It stretched 65 feet in length with a wingspan just over 90 feet, and it was powered by a trio of Armstrong Siddeley Jaguar radial engines rather than the Awana's pair of Napier Lions. Cruising comfortably at around 90 to 95 miles per hour with a top speed near 110 miles per hour, the Argosy could haul a maximum weight of about 19,200 pounds into the air, a testament to how far the company's understanding of large biplane structures had come since the Awana's troubled flying career. Fittingly, it was Imperial Airways that put the type to work, flying passengers in comfort on routes across Europe where just a few years earlier, the Awana had struggled merely to keep 25 soldiers airborne for a few hours at a stretch. The Argosy went on to become one of the more successful and fondly remembered airliners to carry the Armstrong Whitworth name, quietly proving that the lessons learned from the doomed troop transport hadn't been wasted after all. That wraps up our look at the fascinating story of the Armstrong Whitworth Awana. It's always incredible to see how even the forgotten giants of the interwar period helped pave the way for the successful aircraft of the future. Before we go today, I want to take a special moment to say a massive thank you to each and every one of you. Our community has just crossed 5,000 subscribers, and I'm truly blown away by your continued support, your insightful comments, and your shared passion for aviation history. Reaching this milestone means the world to me, and it's all thanks to you tuning in. If you enjoyed this deep dive into one of Britain's more obscure flying behemoths, please be sure to hit that like button and double-check that you're subscribed so you don't miss out on any of our upcoming videos. We've got a lot more incredible aviation history lined up for you. Also, drop a comment down below and let me know which experimental or forgotten aircraft you'd like to see featured next on the channel. Thank you so much for watching, fly safe, and I'll see you in the next video.